All right, here we go. New chapter, chapter three. Lots of definitions today. Lots of definitions today. All right. In this chapter, this really separates those who really do the work or understand the material from those who don't. And this is probably one of the first of the challenging chapters in the book. It's not. I'm trying to make it up a little bit more than it is, but I will say you will notice it's more difficult than the previous ones. How about that? So you have to do the work and you have to understand. If there's something you don't get in this chapter, we need to talk. So see me in the hallways before school, after school. Golf is over for at least until girls' golf starts in the spring. So I got plenty of time to help you. All right. If you work and you understand it, you'll get an A in this class. Here we go. So this entire chapter deals with one basic construction, and that one basic construction is there are going to be two lines drawn on a plane. When two lines are drawn on the plane or a plane, there's only two possibilities. The two lines will either intersect or they don't intersect. Okay. So if they don't intersect, we have a word for it. And if they intersect, well, we say they intersect. The but here is that if we extend this to three dimensions, right? So now the two lines are not necessarily on a plane, right? Well, if they are on a plane, they could intersect, right? And they must be coplanar in order for that to happen, right? But if they don't intersect, if we consider three dimensions, there's actually two possibilities, right? So if they don't intersect, there's actually two possibilities. So possibility number one, right? You probably understand. That means that they're parallel. So when they are parallel, well, clearly the two lines don't intersect, but it also means that they are coplanar. That means they have to live on a plane together for them to be parallel. Big picture, we're talking about two lines that do not intersect. So flavor number one, they live on the same plane, therefore they're parallel, right? We have a symbol for parallel. It looks like railroad tracks, and that's the symbol in red there, right here. That is the symbol for parallel. So line AB is parallel to line CD. And just remember, background knowledge, they must be on the same plane for them to be parallel. Now, I did say there's two flavors. So flavor number two is they're not going to be right on the same plane. So skew lines. It's kind of hard to draw in two dimensions, but this is what it would look like. So I have two lines. They're definitely not coplanar. One goes through the plane and one is on the plane, and they don't intersect. So we wouldn't say those two lines are parallel. We would say those two lines are skew. But in order to be skew, you must be non-coplanar. So if you don't intersect and you are coplanar, you are parallel. If you don't intersect and you are non-coplanar, then you are called a skew line. All right, a couple quick notes. Many things can be parallel, not just lines, but segments and rays can also be parallel. So these two lines are parallel, these two segments are parallel, these two rays are parallel. All right. Now recall that when lines intersect, they can only intersect at one spot. Now, I have a lot of lines in that picture right there, but any two lines can only intersect in one spot. And they also have to be coplanar for them to be intersecting as well, too. So those 2 points. For two lines to intersect, just like if they were parallel, they must be coplanar. And if they do intersect, they can only intersect in one point. Okay. For non-intersecting lines, those are the parallel on the left there and skew on the right, right? They can be coplanar or they can be non-coplanar. All right. So let's answer some, or let's see some questions about these concepts. So here we go. Here's the picture. Red looks like there are two lines and black looks like there's two segments. So the first question is, does segment PQ intersect segment RS? So does black intersect with black? And the answer is nope, they do not. Then it says, does red intersect with red? And clearly red does intersect. So that one's a yes. Now it gets a bit more complicated. So we got to think about the definition here. So there's the symbol for parallel, and it says, are the two lines parallel? Well, if the two lines are parallel, then they cannot intersect. And since these two red lines intersect, and the answer there is no, here comes the tricky one. Are the two segments parallel? Well, if they're parallel, then that means that they don't intersect. And clearly the two black lines or two black segments don't intersect. but we're going to extend the definition of parallel for segments, and we're going to include the line that contains the segment. So if the line that contains the two segments, one red one for PQ, one red one for RS, if the lines that contain the segments intersect, then we would say the two segments are not parallel. Even though they don't intersect, we have to include an additional part of the definition for segments, and that also include rays as well too. Right? So in order for the two segments or two rays to be parallel, then the lines containing them could not intersect. If that does not make sense to you, replay that statement again. All right. All right, so let's talk about planes. Can planes be parallel? Sure can. Two planes are parallel when they don't intersect. Think of a box. So there's a box right there. I got a top and a bottom. So plane X and plane Y, top plane is X, the bottom plane is Y, do not intersect, therefore they are parallel. There's actually four sets of planes there, or three sets of planes there that don't intersect. The left and the right don't intersect, the top and the bottom, and the front and the back don't intersect. So we could say plane X is parallel to plane Y. Remember, the names of a plane can either be the corners, right? Now remember, planes don't have corners, they go on forever, but we draw them with parallelograms, or we represent them with parallelograms. So I could say plane EHG is parallel to plane ADC if I wanted to. All right, and then basically, if there are things on plane X and there's things on plane Y, well, then they potentially could be parallel to each other, right? So, for instance, EF is a segment, and it would be parallel to the plane, right? HG is a ray, and HG would be parallel to plane Y. So anything on plane X would be parallel to plane Y. Now, notice what I'm not saying. I'm not saying a line on X would be parallel to a line on Y. I'm just saying that anything on X would be parallel to plane Y. If that didn't make sense, once again, play the video again. All right, there's a but here, right? The things on, and I just said it before, the things on X aren't always parallel to the things on Y. They could be skew, right? They could be parallel, but they're just not always parallel. So for instance, EH is skewed to AB, right? So that EH is on plane X, AB is on plane Y, and they're not parallel, they're skewed. All right, on to the big topic today. So the big, and I mean big topic, and very important topic, right? Painful to some because there's a lot of definitions here that we're going to be writing down. All right, so here's the new idea. We're going to make a construction. A construction is just things that I write on a paper. So I'm going to take two coplanar lines. So there's line H and there's line K, and I'm going to intersect those two lines with a third line. So the third line is going to be line T, and notice it intersects H and it also intersects K. So this is the construction that we'll use for the entire chapter. So that's the entire construction. Two lines intersected by a third. Third line has to intersect both lines, though. All right, two lines cut by a third or intersected with a third. All right, painful, painful, painful. All right, so here we go. This creates 8 angles, lots of them, 8 in fact, right? So we're going to start off easy, right? We're going to label those angles. So first off, the line that intersects H and K is called a transversal. Notice I called it line T. All right, so that transversal is that line that intersects those two other lines. Now it says 2 or more. Eventually we'll get to more, but we'll start off with an easy one with just 2 lines cut by a third. That's a transversal. Pause the video if you need to write that down. H and K have to be coplanar, right? T is the transversal. So here comes the challenging part. This construction will result in 8 angles. Now you can label these angles any way you'd like. I'd like you to label them like this so that we can be on a common page. So from top to bottom, left to right, we would create with this constructions angles 1, 2, 3, 4, 5, 6, 7, and 8. In your book of truth, go ahead and do this construction and write those angles because every single angle is going to get multiple names. That's the pain part. Okay, here comes the pain. So these angles get not just one name, but many names. So here we go. We're just doing one at a time. So imagine if I only list the angles that are between line H and line K, those angles right there that I just are blinking in red, 3, 4, 5, and 6. They are between H and K, so we might say they're on the inside of H and K. Therefore, we will call these angles the interior angles. So angle 3, angle 4, angle 5, and angle 6 are interior angles. Next thing in your book of truth, right? Before we talk about exterior angles, we have interior, we have exterior. We're going to give those interior angles some more names. So here we go. So we're going to talk about the interior angles, 3, 4, 5, and 6, but I'm only going to list 2 of them. Notice I made 3 and 6 red, and I made 4 and 5 blue. So if we think about just 3 and 6, 3 is on the top, 6 is on the bottom, 3 is on the left of the transversal, 6 is on the right of the transversal. I'm kind of like alternating between the two positions, top to bottom, left and right, which is why we call these angles, the 2 red ones and the 2 blue ones, we call them alternate interior angles. These are 2 non-adjacent interior angles on the opposite sides of the transversal. So that would be angle 3 and 6 are alternate interior angles, and angles 4 and 5 would be alternate interior angles. All right, so I'm going to continue on. Just remember, you can pause the video. All right, there's more. Oh, there's lots more. All right, so this time I'm going to stay on the same side as the transversal. I'm still on the inside, but I'm on the same side. So notice 3 and 5 are blue, and 4 and 6 are red. So those are going to be called same side interior angles. So those are 2 interior angles on the same side of the transversal, right? So that would be angles 3 and 5 are same side interior angles, and angles 4 and 6 are same side interior angles. These are just names. They can be in your book of truth. You will have them memorized quickly. All right, now let's talk about those exterior angles. So the exterior angles, I just made them red, are 1, 2, 7, and 8. Okay, you kind of probably know where this is going. All right. For exterior angles, remember, if interior angles, we had alternate interior angles. Well, we also have alternate exterior angles. So those would be angles that go from top to bottom and from left to right. So 1 and 8 are alternate interior angles, and 2 and 7 are alternate interior angles. 2 non-adjacent exterior angles on the opposite sides of the transversal. If it seems overwhelming right now, we're going to use these words enough. They will not be overwhelming after we use them. Okay, here we go. More. Well, you can probably imagine from the colors and from their positions that these would be the same side exterior angles. So 1 and 7 are same side and exterior angles, and 2 and 8 are same side exterior angles. A little bit overwhelming? A little bit. All right, more pain. Last one. Really frequently used. It's the hardest one to describe, but it's also, once you use it, easy to remember. Okay, so here's this idea. The idea is pick an angle, any angle. I'll pick angle 1. Notice I made angle 1 red. Angle 1 is, for those 4 angles there, 1, 2, 3, 4, is in the upper left position. If we go to the bottom 4 angles, angle 5 is in the upper left position. Look at angle 4. Angle 4 is in the lower right of the top 4, and angle 8 is in the lower right. So these 2 angles are on the same side and basically the same position, upper right or upper left, lower right, lower left, that sort of thing. We're going to call those angles corresponding angles. Those are 2 angles in the same position relative to the 2 lines. So same side, same position, I like to say. So there's 4 pairs of these. Each one are corresponding angles: 1 and 5, 2 and 6, 3 and 7, 4 and 8. Okay, that's the pain. The pain is that all of those angles, all 8 of the angles, have multiple names: interior, exterior, same side, corresponding, alternate, right? There's lots of names for all of them. And as I stated earlier, I said that as you use these, it will be easy to remember them. It may not be easy right now, but it will be. So they're just names today. Next class, we're going to get a relationship, right? For each one of those definitions, we're going to get, I call it a so what. So what that they're alternate interior angles? Well, you're going to get a so what. In other words, you're going to get a consequence if they're alternate interior angles. Then you're going to be able to say something, right? Well, that does it for the class. Now, for homework, you're just going to be naming angles and naming the relationship, right? Okay, so that will do it. Here is your homework. Good luck. If you run into a problem, just ask. I'd be more than happy to help. See you next class.